So today we will begin from part B, that is your analytical chemistry, the use of ammonium and sodium hydroxide, right?
Yes.
So to begin with the B part, let us just simply revise what we have studied till today. In our first A part, the A part was our acid, bases, and salt, right? I'm just revising you the topics. Okay, so in lesson number 3 A part, we studied about acid, bases, and salt. In that we studied that which compounds do we call acids and why, based on their properties, that can be physical, that can be chemical.
Yes.
Then we learn about their classification on the basis of the sources, on the basis of their strength, right? And on the basis of the number of hydronium or hydroxyl ion present. Then on further classification, we read about the weak acids and strong acids, dilute acids and concentrated acid. Then we learned about the basicity of acids. Then we came across our two important theories that were given by two scientists, Arrhenius theory and the Bronsted-Lowry theory. Going
Yeah.
further in the chapter, we learned the difference between bases and alkali or alkali, whatever you want to say. Then we learned how to measure the strength of the acids or bases, that is with the help of the pH scale. Then we
Yeah.
learned about the color changes that occur during the litmus paper, phenolphthalein, methyl orange. Then going further, we learned about the different kinds of reactions taking place in terms of pH, like acid rain, its effects, harmful effects, its formation, how it is formed and how it affects our atmosphere. Then we learned about the uses of acids and bases, that where our acids are used in our daily life and where the bases are used in our daily life. Then we came across the salts, right? In salts, we learned the method of preparation. How do we define a salt? Firstly,
Learned about complex salt, basic salt, mixed salts,
yeah.
hydrated salts.
Then we learned about two basic kinds of salt, the acid salt and the basic salt. Then after acid basic salt, we learned the further classification, that was a complex salt. Then
Acid salt,
double
basic
salt.
salts, mixed salts, double
Hmm.
salts.
Yes. Then we learned about the method of preparation, that some salts are formed by the method of direct combination, some are formed by the precipitation, some are formed, there were some examples that can be soluble salts and insoluble salts with the formation of precipitates or the color changes. The method used was a double displacement or double decomposition or titration method, in which we used burette, filter paper, conical flask, Bunsen burner, right? And then at last we evaporate the salt, so we get the crystals. Then at the last we learned about the hydrolysis of salt in forward reaction, that is called neutralization, and when the reaction is backward, we call it hydrolysis.
Hydrolysis.
Then at the end of the chapter, we learned the three important definitions: efflorescence, deliquescence, and the water of crystallization. Yes. So this was all our lesson number 3A part.
Yes, ma'am.
Now we are going to start our lesson number 3B part, that is your analytical chemistry. In this analytical chemistry, you are going to read only about the two salts, that are the ammonium and the sodium hydroxide. Right. So basically, what we are going to study in this analytical chemistry, it is a part of the salt. Right. So this particular part deals with the salt and its solution. Salts and the solutions. So this analytical chemistry, in this there are many other classification, but in your syllabus there are ammonium and the sodium hydroxide. Okay, so how do we, the firstly the name of the chapter, that is the analytical chemistry. How would you define the analytical chemistry? So the analytical chemistry, today we are going to start our B part, that is your analytical chemistry. So our analytical chemistry, how do we define? Like if we talk about the organic chemistry, it means we are going to learn about the organic compounds. like hydrogen and carbon. That's why we call it the hydrocarbons, right? So analytical chemistry, it deals with the two kinds of things. The first one is about the qualitative, right? The qualitative methods, and it study the quantitative method, the both things. So the analytical chemistry, we in our daily life, there are many streams, or you can say very much qualification, classification of chemistry, like organic chemistry, spectrochemistry, physical chemistry. Analytical is one of them, right? Then you have biochemistry. So it's just a part, analytical chemistry, right? So this analytical chemistry, it deals with the experiments. These experiments can be qualitative as well as the quantitative purpose. So how do we know that it is a qualitative? How do we define the word qualitative, and how do we define the word quantitative? So when I'm talking about the word qualitative, it means that quality, we have to just find out, as I told you, that we are going to study mostly about the salt, right? So
Yes.
in the qualitative analysis, I mean that we are going to learn about the identification of a known salt. What happens in qualitative chemistry is that a salt would be given to you. It can be white colored, it can be green colored, as I told you, it can be blue color, and you have to perform certain test. And after performing certain tests, you would conclude that it is which kind of salt. Like for example, if a salt has been given to you, that is potassium sulfate, or simple a blue color salt has been given to you, okay, so generally we can just get an idea that blue is copper, right?
Mm.
So but copper, it can be copper chloride, it can be copper sulfate, it can be copper nitrate. So for example, there is a blue color salt, so obviously it is copper sulfate, right? So you will perform certain tests for this copper, and you will perform certain tests for this sulfate. When there are 2 or 3 tests performed and we are confirmed that this is the copper and this is the sulfate, then we conclude that this particular salt is the copper sulfate, right? So color plays an important part in the identification. So
Yeah.
this is how we define the qualitative analysis, right? The quantitative analysis, by the word quantitative analysis, I mean that whenever we are performing any experiment, the quantitative, the how much quantity you have been taking. Suppose for example, if this is a test tube, right, and you are testing any salt, right? So you should not take such an excess amount of salt, like for example up to its rim, right? The quantity of salt also matters. So you have to just take, normally the amount of salt we take for the experiment is just a small spatula or one small spatula. You know spatula, the spatula is a kind of the spoon shaped. This is the spoon shaped part, and this is the flat shape part. So what is the use of this? It is used for picking up the salt from the bottle, and this part is used for the stirring, right?
Yes.
So this is a spatula. So it is just half a tablespoon, if I just make you understand. So normally we just require only this much quantity of salt to perform an experiment, not much more than that, right? So analytical chemistry, it just deals with the qualitative and the quantitative purpose. A qualitative purpose means that qualitative analysis includes the identification of the unknown substance. We don't know that substance is a salt or it is an acid, right? Mostly, in most cases, it is a salt. And by the quantitative, I mean the quantity you are taking for the experiment. You should not take an excess quantity. By taking an excess quantity, the reaction will go on the other hand way, right? Like for example, I made you understand about the two. So when I gave you introduction, I just made you understand the two case of the copper tetramine copper sulfate. Do you remember the reaction when I was giving you the introduction of this chapter?
Could you just repeat?
Yeah, when I was giving you the introduction of this chapter, I made you understand this reaction, this particular reaction, that when the copper sulfate reacts with a base, that is NH4OH ammonium hydroxide, we get ammonium sulfate and copper hydroxide. Now you know very well that copper sulfate is a dark blue powder substance, right? In terms of solution, it is a dark blue substance, a dark blue solution. But here it is for the salt form is copper hydroxide. So the color of this copper hydroxide is the pale blue, and also it is a sulfate. So it is soluble. But when you are taking an excess amount of ammonium salt, as you can see, We have taken here ammonium hydroxide and ammonium sulfate. So the ammonium salt is taken in excess, right? So when it is taken in excess, as you can see, we are getting a complex salt and the color changes to the inky blue. So that's why we have to just go through the both the aspects of the things, like the qualitative and the quantitative, both. Okay. So we
Yes,
have
ma'am.
to not go in the excess. If we go in the excess, the reaction will take the other way. So this was all about your introduction, right? So introduction, it deals with the experimental study both of the qualitative and the quantitative purpose. The qualitative purpose includes the identification of any unknown substance by chemical means. Chemical means it has to go through the series of reactions. Also, the color changes and the appearance also play the part, but the small part. We just get an idea. Then the chemical test which we are going to perform, it includes the use of sodium and the ammonium hydroxide. That's why the chapter contains the two salts, ammonium and the sodium hydroxides. Right? And what we have
Yes,
to do, we have to perform these chemical tests. We have to use these two salts in this particular chapter I'm talking about. We have to use these two salts, and after using these two salts, we have to observe. What do you have to observe? The original color and the color after the reaction. The solubility, how the precipitates are being formed, the soluble ones or the insoluble ones. You have read that what are the soluble salts and what are the insoluble salts very well in the previous chapter, right?
yes,
And
ma'am.
so why we are using these particular two salts, that is the ammonium and the sodium hydroxide. Now, as you know very well, the sodium hydroxide is a strong alkali. It is a base, obviously, and also it is a strong alkali. Since it is a strong alkali, it dissociates completely. I mean, it is a strong alkali, not a weak alkali. So how do we define the strong alkali? That it dissociates completely into the solution to give the large amount of hydroxyl ions.
Yes,
Weak alkali dissociates partially to give the lower concentration of hydroxyl ions, right? So whenever we are performing such reactions, the sodium hydroxide is a strong alkali, and it goes and dissociates completely to give the salts. Also, we have taken ammonium hydroxide. Why this particular hydroxide we have taken? Because it is a weak alkali. It also dissociates partially to give the sufficient OH minus ion. So one case we have taken stronger alkali. In other case we have taken the weak alkali to get the respective soluble salts or the insoluble salts. Right? So this was your introduction of the analytical chemistry. Till now, have you understood that what is the analytical chemistry, what factors it include, and why
uh,
we are using this two
yes, ma'am.
particular?
Yes, ma'am.
Okay. Now coming towards our B section, that is the color of the salt. So you know very well the salt. How do we define a salt? That a salt is generally colored ions. It may be cation or anion. You know very well the charges present in cation or anion. Right. Suppose, for example, if I am taking any salt, if I am taking NaCl, so obviously it is going to dissociate in the ionic form, that is Na plus and Cl minus. Right. If I am taking another salt, potassium sulfate, then K plus and SO4 minus. So it means we are getting a cation and an anion. Right. Also further, if you are
Right,
taking NH4OH, then NH4 plus OH minus. These all are salts. Why these all are salts? Because they contain one acidic radical or acidic cation or an anion. Right? Now, the salts of the groups in the periodic table 1 to 13 to 17, they are normal elements. Means the transitions elements we have not included here, the center series. Right? So, the group 1, group 2, 13 to 17, group 1, group 2, you know, they are the strong alkali. 13 to 17
yes,
belongs to the non-metals, right? So these are the normal elements and they are generally colorless. Then we have 3 to 12. That is a transition elements. I told you very well when we were studying the periodic table that the transition elements are those so which shows some transition, right? So transition in which cases it can be in the form of their color, it can be in the form of their state, right? It can be in the
yes,
form of their properties. For example, basic salt which we are studying is copper sulfate. So copper does not lie in group 1, group 2 or group 3 to 17. It lies in the transition series, right? Then we can consider iron. You know very well the precipitate forms of iron is green color. right? Then we know zinc. The zinc forms gelatinous white salt, which is insoluble, right?
Yes, sir.
Iron also forms two kinds of salts, that is iron hydroxide, that is in the form of valency 2, and iron 3 hydroxide, that is you can call ferric hydroxide and call. So one forms the dirty green and the other form the reddish brown precipitate. So why these color changes are being seen, that's why it is included in the transitions elements, right? That's
Yes,
why
sir.
we are not including it in group 1, group 2 to group 3 to 17. Like for example, if you consider group 17, that chlorine, it is a gas, right, which it has a pungent smell. Also ammonia NH4, it is composed from nitrogen and hydrogen, it is not an element.
Yes,
Understood?
sir.
So here, as you can see, some colored cations and some colorless cations are being given to you. So firstly, coming towards our colorless ones. Colorless means that belongs to group 1, 2 or 13 to 17. Right? So first let's
Yes.
see that the first one has been given to is sodium. It belongs to group 1. You know this very well now as we have studied this chapter. Then we
Yes,
have
sir.
potassium, as you can see, group 1. Magnesium, group 2. Then you have after magnesium.
Calcium, barium, which is of group 2, and then aluminum, which is
Yes.
of group 3, and then
No, the
strontium like that.
aluminium is from group 13, not from 3.
Oh, 3A means 13.
Yeah, that's 13. Not 3A means no. 3A is the other category. You have to just go through the main groups. That is a subcategory. These are the main groups.
Yes.
Then you have more. The what does the symbol SN stands for?
Strontium,
Okay. PB.
lead.
SN stands for stennis, not strontium. Strontium goes for ST.
I don't know because I've studied only till 20 elements. So,
Yeah. Okay. No problem. PB stands for plumbum or lead.
yes,
Plumbum
yes,
is its Latin name and lead is its other name. Then you have Zn zinc. CD is the cadmium. We use it in the form of electrolyte to conduct electricity. Cadmium rods.
yes,
Then
yes,
we have Hg, mercury. Mercury, you know very well, it is liquid at room temperature, right? And the last one is your
yes,
ammonium, NH4. And now, as you can see, NH4, no such groups have been given to you for NH4, that is ammonia, because it is formed from the two elements, nitrogen and hydrogen.
covalent compound.
Yeah, it's a compound. So these are the colorless cations, which are from the group 1, 2, 1, 2 to 13, 17. Right? Now coming towards our colored cations, you know very well why we are calling it cations, because they all have the positive charge, right?
Positive charge.
Yeah. So coming towards our colored cations, the first one is your copper. Then you have Cr. Cr stands for, any idea?
Chromium. Chromium.
Chromium. Good. Mn stands for
Manganese.
manganese. Fe is for,
Iron.
yeah. And similarly, Fe exhibits two valency, Fe2 plus and Fe3 plus. Then you have
Yes.
Co. Co stands for
Cobalt.
cobalt. And Ni stands for
Nickel.
nickel. So these all elements, they are from, as you can see, copper. We know very well because we have been studying the about copper from so far. So copper comes under group 11. That's the transition series, and its color is blue, right? And it green is when it gets oxidized. Then we have chromium, belongs to group 6. Its color is green. These all are the metals very well. So manganese,
Yes.
its original color is pink. Then we have iron, that's green. Then we have other one that is yellow or brown, that we call the rust, right? The Fe3 plus. Then we have cobalt, it's or blue or pink depending upon its state. And the last we have
Yes.
nickel, that is its green. These we read about the colored cations that are having the positive charge. Coming towards the anions, the colorless anions include SO3. As you know very well, anions means that carries the negative charge. So negative in the
Yes.
periodic table are towards the right hand side, right? Like for group 17 can be considered as anions, right? As you can see, the chlorine has been given to you, that belongs to group 17. Bromine has
Yes.
been given to you. Then you have oxygen belonging to group 16, right? sulfur has
Yeah.
been given to you. Then coming towards our gases form SO3, sulfurous, SO4, sulfate, CO3, carbonate, right?
Yes.
Then NO3, nitrate. Then
Nitrate.
HSO3, bisulfurous also you can say. Then HSO4, bisulfate. Then it is
Bisulfate.
HCO3, bicarbonate.
Bicarbonate.
Yeah. And PO4 is,
Oxide, sulfide, and then PO4, which is the phosphoric, I think something.
no, not acid. H plus is not there. It is
Not acid,
phosphate.
I know. Phosphate, yes.
Yeah, it's phosphate. These are the colorless anions, and you can predict their groups, respective groups present. Like chlorine and bromine are the 17th group. Then oxygen and sulfur also you can predict very well. Right? Then
Yes,
coming
ma'am.
to our colored anions, then we have MnO4, that is permanganate, and this Mn was manganese, right? And MnO4 is permanganate. That's original color is pink or purple. In laboratory for the titration we use potassium permanganate, which is a dark purple liquid. Like when I told you titration, you must have noticed that, understand, there was a long tube which we call the burette, right? So we
Yes.
filled in preparation of salt, we used to fill the acid in it. You remember very well.
Yes.
But yes, but when you do titration of some other salts, then potassium permanganate is taken in that burette, that is of dark purple color. Okay, then you have Cr2O7, that is dichromate. Why it is we are calling it dichromate? Because di means two, that is Cr. So it is dichromate. The original color of it is orange.
Yes, ma'am.
Okay, so till now we have studied the analytical chemistry. How do we define analytical chemistry? Then the analytical chemistry, the terms we use, qualitative and the quantitative, the test we use, the particular salts we use, and why do we use a salt. Now we have learned about the color of some salts related in reference to some groups, like group transition elements go through series of changes, while other hand, the group 1 to 13 to 17, they does not change the color and they are the colorless. Okay.
Yes.
Okay. Now first we are going to study the reactions which are related with our sodium hydroxide. That is a weak alkali or strong alkali?
We are strong alkaline.
Strong alkali. Okay. So we have taken some metals here. That is the some cations here. The first one is the calcium. Second one is magnesium. The third one is iron here. Iron or iron, as you can see. Then we have copper, we have zinc, and we have lead. Right? So these are some common ions. Then we have
Yes.
taken the salt. Just pronounce the name. What is this one? The name of this salt.
Calcium nitrate.
Okay. The next one.
Magnesium chloride, and that's
Yes.
um, iron sulfate, and then that's ferric chloride, copper
Hmm.
sulfate, zinc sulfate, and lead nitrate.
Good. So we are doing the reaction of the salt with bases. And which kind of base
Yes.
we have taken here? We have taken a strong alkali here. Right?
Yes.
So the first, we have taken the salt calcium nitrate and we are reacting it with the sodium hydroxide, which is a strong alkali. The color original of this particular salt, that is the calcium nitrate, was white, right?
Yeah.
When it goes under the reaction, it is a kind of the double decomposition reaction or double displacement reaction in which the calcium was replaced with the OH ion and the sodium got replaced with the nitrate ion, right? So the product form will be calcium hydroxide, like Ca plus and NO3 minus, Na plus and OH minus. Okay. Then
Yes,
we
ma'am.
have calcium hydroxide and sodium nitrate. Now, originally the color of the salt was white when we took calcium nitrate. But when we get the product, we can see the calcium hydroxide came in the form of precipitate. And which kind of precipitate it is? It is a kind of insoluble
Soluble.
precipitate. Yes.
Yes.
And insoluble with which color? Originally it was white. And after the
Mm,
reaction also it was white.
white.
Not we cannot say the pure white as the original one, but the slightly whitish color. Okay.
Yes.
Coming towards our second reaction, that is with the magnesium. We have the salt we have taken is magnesium chloride, that is in the form of white color. That is in the form of white powder, you can say. When it goes through reaction with the sodium hydroxide, the Mg being a metal gains positive charge, right? The chlorine is a non-metal negative charge. Then we have sodium which gains a positive charge, and NOH which has the negative charge. So we'll just replace the ions of all the reactants, and we will get the Na will replace the Cl, will go with the Cl, and we will get the NaCl here. And magnesium will go with the OH, and we will get the magnesium hydroxide here. So NaCl, we have got the particular salt here, and along with that we have got the precipitate, right? So
Yes.
originally the color of the magnesium chloride was white, but when we get the precipitate of magnesium hydroxide, the color changes from white to the dull white, right? And in terms of solubility, if we talk about, the magnesium hydroxide is insoluble, so it means the precipitate forms is not soluble in water, right? Coming towards our third one, that is ferrous sulfate or ferric sulfate. How do we pronounce its name?
Ferric sulfate.
Ferric sulfate. So ferric sulfate is already green in color. These are in laboratory, you might have seen, your teacher might have demonstrate that these are the that kind of the leaves kind of color, green color. That color we have powder, and they have some amount of, you can say, shine in them. Okay, so ferrous sulfate are green, shiny powder or crystals, you can say. When they react with sodium hydroxide, the Fe being a metal goes with the non-metal, that is OH, and we get FeOH whole twice, that is iron hydroxide. Along with that, we get a salt, that is sodium sulfate. Originally, the color of this particular salt was green, but after the reaction, it changes to dirty green. Like some of the brown hints have been given to the color. Talking about the solubility, the FeOH whole twice, that is your iron hydroxide, is insoluble salt, insoluble precipitate which is formed. That's why the arrow has been going towards the downward. If the gases have been produced, the arrow would have been got in the upward direction, right? Then we
Yes.
have FeCl3, that is brown in color. When it reacts with the sodium hydroxide, we get NaCl and FeOH whole thrice, that is iron 3 hydroxide. The original color was brown. As you can see, a deliquescent has been written here. So deliquescent means that changes into solution or in the powder.
A solution where it absorbs moisture from the surrounding to become a solution.
Yes. So this particular salt goes with reaction with a base or alkali to form NaCl and iron hydroxide. Now the original color was brown, and after the reaction with this particular alkali, the color changes from brown to the reddish brown.
Reddish brown.
Yeah, which is insoluble. Now the question comes that the reaction of this particular salt with this particular base or alkali, or you will be given to give an example of some soluble or insoluble salt of calcium or of iron or of zinc. This kind of questions will come. So basically you have to not just learn about the color changes, but also about the solubility also.
Yes, ma'am.
Then you have copper sulfate. You know very well copper sulfate has been come many times. That is blue in color. When reacts with NaOH, it forms sodium sulfate. Now you can predict that it is a basic salt, not an acid salt, right? Am I correct?
Yes. Yes.
So it forms copper hydroxide, which is in the form of precipitate. Since the copper sulfate was blue in color, after reaction with an alkali, the color changes from the blue to the pale blue, and it means the
Pale
color
blue.
fades. Yeah, the color starts fading. That is the pale blue, and also it is insoluble. So it is not necessary that all the copper salts are soluble. That's why a chart has been given to you: the soluble salts and the insoluble salts. Coming towards our zinc sulfate, ZnSO4. These all are the elements of the transition series, right? Except I guess magnesium.
And calcium also.
Calcium also, yes. Except magnesium and calcium. Then coming towards our zinc sulfate was white in color. The important one, as you can see, the zinc sulfate is white in color. When it gets reacted with a strong alkali, it forms sodium sulfate and zinc hydroxide. Since the original color of zinc sulfate, that is the salt, was white, and after the reaction, the color changes to
Gelatinous white, which is soluble in
which is
excess of
soluble. Yes.
NaOH
And now,
solution.
yes. And now here comes the important question. When you are taking the sodium alkali, we have taken strong alkali in excess quantity. This is the first step of the reaction, and when this precipitate, zinc hydroxide, is made to again react with excess sodium hydroxide, means the quantity of sodium hydroxide has been increased. We have taken twice. It
Yes.
forms water and sodium zincate. Are you learning how we are pronouncing it? N stands for sodium and ZnO2 is zincate. So this is
Yes.
sodium zincate. The color was originally white. When we just use a small quantity, the color was the gelatinous white. But when we use the the sodium salt in excess quantity, the color changes to colorless solution. Understood the difference? That's why it's coming under the analytical chemistry. We are going in terms of qualitative and the quantitative both. So
Yes,
here
ma'am.
we are going through the qualitative, obviously, because we are just identifying the unknown salt, and also in reference to the quantitative. The last one is your lead nitrate. It is white in color. When lead nitrate goes in reaction with strong alkali, it forms PbOH, that is the lead hydroxide, along with sodium nitrate. Sodium nitrate is the particular salt, and the precipitate formed here is lead hydroxide. The original color of lead nitrate was white. Also, lead nitrate, it is a shiny white crystals or shiny white powder, right? Original the color was white, and after the reaction with an alkali, that is a strong alkali, sodium hydroxide, it forms lead hydroxide precipitate, which is the chalky white. That means from the original white color, the color changes to chalky white. Okay.
Yes, ma'am.
But when we are taking this sodium hydroxide, that is a strong alkali in the excess quantity, the first step we got the chalky white color. Now, and as you can see, this is the soluble. So when this chalky white soluble precipitate is made to further react with the strong alkali in excess quantity, we got water, obviously in the form of water vapor, and that is Na2PbO2. Na means sodium, PbO2 means plumbite, right? Not plumbate.
Yes.
So this is the sodium plumbite. Why we are going towards our second step? Because our first step is soluble, right? In all the above cases, as you can see, 4 cases we studied, the 5 cases, all the 5 cases were insoluble precipitates. That's why the reaction stopped at that point. The last 2 cases, we are getting the soluble salts. That's why we just tested out with the excess quantity. And we noticed that there was a color change. So this
Yes,
was
ma'am.
all about your reaction with the sodium hydroxide, which was the strong alkali. Okay. Now
Yes,
coming
ma'am.
toward our second part, that is a reaction with the ammonium hydroxide. Ammonium hydroxide, some key points related to ammonium hydroxide is that ammonium hydroxide, you can give me some key points that why we have taken ammonium hydroxide. I just told you.
Ammonium hydroxide is a weak base, and
Hmm.
it precipitates then it precipitates excess of NH in the excess of NH4OH, and the concentration of OH minus ions in the NH4OH is low, so it is a weak base, and it
To
does
be
not
more
produce
precise, yes, to interrupt you, to be more precise, don't call it as a weak base, call it a weak alkali, right?
weak alkali. Yes.
Hmm. It is a weak alkali. It will dissociate partially in the solution. Partially means
Yes.
not completely, obviously, giving some amount of hydroxyl ions in a lower concentration. But it is
Yes.
going to dissociate, but partially, right? Okay.
Yes.
So same salts we have been taking again, the iron. The first one is your calcium. Second one, again, we have taken magnesium. Third, as you can see, again, 2 cases of iron. Then we are taking again copper. Then we have zinc and lead. All the ions are just repeated. We are just testing out with the strong alkali and a weak alkali. Now, coming towards the weak alkali, the first part, as you can see, we have taken calcium. The salt, we have taken calcium nitrate, right? So the calcium nitrate originally color, you know very well that it is white in color. So again, as you can see, again, no color changes have been written here. Okay. So you must know that when we have studied our first part that the color of the calcium nitrate is white. Now, as you can see, no precipitate of calcium hydroxide is formed. Why there is no no precipitate is formed? As you can see, because the concentration of OH ions is low and it cannot form precipitate. You know very well the precipitate we have in this case, as we have studied sodium hydroxide, it was a strong alkali, means dissociated completely, produced large amount of hydroxyl ions. But in the case of weak alkali, we are getting very low concentration of hydroxyl ion that the precipitates are unable to be produced. That's why in our first case there is no precipitate formed, because the ions are not sufficient. Which ions I'm talking about? The hydroxyl ions
OH
are
minus
not
ions.
sufficient. Yes, they are not sufficient to produce the precipitate, their respective precipitate. We won't say that the hydroxyl ions is not produced. We would say that its concentration is reduced, right? You have to be very much accurate and precise with your words you are using, with the terms you are using: low, high, more, less, excess or reduced. Okay, now coming towards
Yes,
our
ma'am.
second ion, that is your magnesium Mg2 plus. The salt you are taking here is Mg chloride. As you know, magnesium chloride is white color, shiny white color salt. When it goes in reaction with the NH4OH, that is your ammonium hydroxide. Let me show you a kind of reaction how will be how it will go. For example, we have taken MgCl2 and it is reacting with NH4OH. So magnesium is a metal. It will have positive charge. Chlorine will have the negative charge. Ammonium NH4 will be having positive charge and OH will be having the negative charge. So the reaction will proceed that with the exchange of the ions. So Mg will go, positive ion will go with the negative one. So here we will get magnesium hydroxide plus NH4Cl. So can you tell me what is the precipitate and what is the salt which is produced here?
MgOH is a salt and NH4Cl is a NH4Cl is a salt and Mg hydroxide is a precipitate.
Yes. And the arrow should go upward or downward?
Downwards.
Downward. Okay. This was the reaction which I made you understand. MgCl2 plus NH4OH, it forms NH4Cl and MgOH whole twice. That is your magnesium hydroxide. Now, as you can see, with the strong alkali also, it was forming with the strong alkali, it was forming dull white precipitate, and also with the formation of NH4OH, it is forming the dull white precipitate, which is insoluble. Okay. In our third case, FeSO4, which is originally green in color, when it reacts with the weak alkali, that is NH4OH, it forms NH4,2SO4. Can you name the salt? What do we call this particular salt?
Ammonium sulfate.
Yes, ammonium sulfate. And this is the FeOH whole twice, that is iron hydroxide. So originally the color was green and it changes to dirty green, which is insoluble. So there is no much major changes in the color. Means the colors are just repeated. Right? You can easily, if you learn the first case, the second case will be learned to you automatically. The main point you have to learn when we have taken the salts in excess quantity, right? Coming towards our
Yes.
third one, that is your FeCl3. So FeCl3, when reacts with the ammonium salts, ammonium hydroxide, it gives NH4Cl and FeOH whole thrice. So FeCl3, originally its color was brown and it changes to reddish brown. No much major changes. The changes are same. Now the most important two salts, as the first one is your copper sulfate, right? Copper sulfate CuSO4, that is originally blue in color. When it reacts with NH4OH, it forms CuOH, that is copper hydroxide, and NH42SO4, that is ammonium sulfate. Ammonium sulfate is the salt and copper hydroxide is the particular precipitate formed, right? So
Yes.
originally the color was blue, but it changes to pale blue. Now there is a very simple reason that why the color is changing to pale blue.
Because the concentration of
Yes.
because of concentration of CO is decreased, I think.
No,
Um,
the simple reason you can say that that the copper hydroxide, it is the precipitate, means the quantity of water has been evaporated, or you can say it has been reduced. So that's why the dark blue color is changing to pale blue color. Understood? And what
Ma'am,
remains
could you
in,
repeat?
yeah, I can repeat. In case of copper sulfate, it is blue in color, right? Here we
Yes.
have taken the aqueous solution of copper sulfate. That is, very well, that is blue in color. And if you are taking then the powder form, that is also it is dark blue color. So in both the cases, if you are taking, we are generally reading about the salt, so we will be taking the aqueous quantity. So in aqueous CuSO4 is dark blue in color. You know very well the aqueous, right?
Yeah.
So when this aqueous copper sulfate reacts with ammonium hydroxide, as you can see, the salt which is present in the test tube, which will be present, will be NH4 जो test tube में रहेगा. जो precipitate form होंगे test tube की rim पर, that will be of copper hydroxide, right? So it means hydroxide means the water quantity that has been evaporated, that has been deposited over the test tube in the form of precipitate. Understood? So the quantity of water, aqueosity has been reduced. That's why the color has been dull. That is from dark blue, it is now changes to pale blue. Now you got the point?
Yes, ma'am.
Right. And now since it is the pale blue copper hydroxide, it is still soluble. Here we have not taken any excess quantity of strong alkali here. Here we are taking the excess quantity of weak alkali. So when this copper hydroxide is soluble is in this case, the first step, that's why we are proceeding with our second step, that is by the taking ammonium salts in excess quantity. It does not mean that we have added ammonium sulfate 2 times. No, it cannot be possible. We have taken 2 different salts here, as you can see, ammonium sulfate, and these 2 were the products, right? So copper hydroxide and NH4 sulfate were the products form, and in that we have again taken our weak alkali, that is NH4OH. So obviously the concentration of the ammonium salts has been increased. And what we are getting here is the tetraamine copper sulfate. How we would be naming? Tetra means 4, NH3 means amine. So tetraamine copper sulfate. Understood how you are naming it?
Yes, ma'am.
Yes. Since it is a kind of complex salt, so the color is changed from pale blue to deep inky blue. Understood? Why deep
Yes.
inky blue? Because as you can see, some amount of water is present here. It can be in the form of water vapor, right? It can be the form of aqueous solution. So that's why we are getting from pale blue to deep blue or inky blue color. Okay. So you can use both the words. You can use deep blue also and you can use the inky blue also. Both are correct. Coming towards the zinc, the students जो होते हैं इस क्वेश्चन में बहुत कंफ्यूज होते हैं कि स्ट्रॉन्ग एल्कलाई में हमने जो केसेस लिए हैं जिंक और लेड के केस में एक्सेस लिया है, राइट? बट इन द केस ऑफ weak alkali, we have taken excess quantity in the case of copper and zinc, not in the case of lead. Okay.
Yes.
So coming towards our zinc sulfate, it is originally white in color. Then
Yes.
zinc sulfate reacts with ammonium hydroxide, gives ammonium sulfate and zinc hydroxide, which is white gelatinous or dirty white. This we know very well. When this white, which is soluble, when this soluble white gelatinous precipitate is again added a small excess quantity of ammonium hydroxide. Excess means we can take instead of 1 the 2 spatula full of ammonium hydroxide, right? So here we are getting again a complex salt. The name of this complex salt, again we are getting 4
zinc sulfate.
yes, tetramine zinc sulfate. The color changes from white gelatinous to the colorless solution. Yes. Coming towards our last case, we have lead. Lead nitrate reacts with ammonium hydroxide, gives gives ammonium nitrate and lead hydroxide. So lead hydroxide is the precipitate and NH4NO3 is our salt. Right. So this lead hydroxide, the original color of lead nitrate was white, and the final color we got was the chalky white, which is insoluble. And in this case, as you can see, we get the soluble one.
Yes.
Okay, so this was all about your chapter analytical chemistry. Coming towards our page number 66, we have the action of alkalis on certain metal. This we have read certain properties in the reaction of the acids and bases also, like Zn plus NaOH. Now, very common example I gave you, the mistake I have seen in papers is when zinc is made to react with NaOH, what students generally do is replace this with this, that is ZnOH and Na. This is the common mistake I see because they just go with reference to the reactivity series. Means the most reactive metal displaces the less reactive one, right?
So most
And they,
reactive is sodium in this case.
yeah, they just make it more complex, and many cases these reaction is formed. So this is not the criteria of the reaction of the metals with alkali, right? While when I talk the reaction of metal with acids, can you tell me which gas is released?
Hydrogen.
Hydrogen. Good. Now, in this case, we are learning the reaction of metal with an alkali. Alkali is in the form of which form? That is the hot form, hot concentrated one, right? So, since it is in the hot form, it means the reaction will be quite exothermic. Evolution of heat will be there. So, metal we have taken here zinc, and as you can see, it is in the hot form. We can take NaOH. Now, what will be formed here, as you can see, it is a kind of combination reaction. So the product form will be Na2ZnO2. How we are getting this? Sodium has the valency 1. Sodium has valency 1 and zincate has valency of 2. By cross multiplying, we get Na2ZnO2. That is sodium zincate, right? With the evolution of the hydrogen gas. That's why we are saying, since it is hot, the reaction is exothermic, some amount of heat will be released, right? Coming towards our other cases, when zinc is made to react with KOH, then it is potassium zincate, and again hydrogen gas is released. In case of lead, that is sodium plumbate. The students generally write plumbate here, like zincate or aluminate. So plumbate, no, it must be plumbite, IT. Then you have the reaction of lead with KOH. So it is potassium plumbite. Then you have the reaction of aluminium, that is sodium aluminate, important reaction of the aluminium. Aluminium with potassium hydroxide, sodium potassium aluminate. Okay. So
Yes,
this is the reaction. Now the last topic, the action of alkalis on oxides and hydroxides. Now there is a word, it is written here, amphoteric. So amphoteric is important. Amphoteric means the particular oxides which react with the acids, with the bases or alkali, जो दोनों के साथ carry करती है reactions, right? So amphoteric, by the word amphoteric, I mean the oxides which react with acids and not or and bases or alkali, जो दोनों से react करती हैं. In both the cases, we would be getting the salt and water. So generally,
yes,
which kinds of oxides and hydroxides we use? The oxides of zinc will be ZnO, right? Aluminium will be
yes.
Al2O3.
Two, three, and
Pb will be PbO.
PbO.
Of Zn, you can, and if you are talking about the
ZnO.
hydroxide, these are the oxides, hydroxides. Zinc will form zinc
ZnOH
hydroxide.
whole twice.
Yeah. Aluminium will form.
Al2 AlOH whole thrice.
Yes. And the lead will form.
PbOH whole twice.
Yeah, lead hydroxide. So these are the reaction of some amphoteric oxide. It can be oxide, it can be hydroxide. Okay, so you have been given both the cases, like the cases of zinc with oxide and hydroxide, the cases of lead with oxide and hydroxide, the cases of aluminum with oxide. Not all the metals and elements goes with amphoteric nature. Only some of them are there. So the first case is with your zinc oxide. When it goes with NaOH, as you can see, there can be no displacement reaction formed, right? No Zn, Na or H2O, no. It will be sodium zincate with the addition to water. Yeah,
H2O.
yes. Then we have zinc hydroxide reaction with NaOH gives sodium zincate with water. As you can see, in all the cases, the salt and water has been formed. In the case
Yes.
of lead oxide, what we are getting?
Sodium plumbite plus water.
Yes. In the case of in the case of lead hydroxide, the same example. In the case of aluminium oxide and hydroxide, we are getting.
Sodium aluminate plus water. Both.
Yeah. In case of aluminium oxides and hydroxide,
KaLO2.
Okay. Now,
KaLO2.
yes. Now let me ask you some
Potassium
form.
aluminate.
Yeah, some formulas. The just a quick revision
Excuse
of
me,
this.
ma'am.
Yes.
Ma'am, our practicals are tomorrow. So, what are the questions mostly asked in practicals? Like, what are the reactions we have to do?
Have you made the practical file?
The teacher has that file. It is like a file we have written the reactions, and then
Hmm.
teacher says we have to we have to just copy it from the board in the classroom. But now the practicals are like we have to study and we
You
have
have
to
to just study
perform
and
them.
conduct.
Yes. So, what are the mostly questions which are asked?
Look, in the case of Viva also might be happening in your syllabus, right?
Yes, yes, there will be also some MCQs also from any chapter,
Yeah.
or I don't know.
Yes. So
We are
look,
not sure.
the kinds of practicals that can be asked will can be cation or anion. Like you and as I told you, a salt would be given to you, and you would be asked it what kind of salt it is, in the name of the salt. So there are particularly three or
Analytical chemistry will be like analytical
yes.
chemistry, acid
In
base and salts will be
yes,
useful in
analytical
this.
chemistry will be, it is an important part. If you are saying that practicals are going to be conducted, they will give you some kind of colored salt and they will ask you what kind of salt it is. Okay, then we can ask you the preparation of salt, how you prepare this particular salt, the name of the apparatus you have been using in the conduction of that preparation of that particular salt. Then also they can give you a litmus paper and they will ask you that this color changes to this. What was that? Acid or base? Like this. Observation based questions, right? Also, majorly from the acid and bases, they can ask you related to the pH. pH, they will not give you pH scale. They will just normally ask you the pH of the human blood, the pH of the acid rain. Then
pH of blood, I think, is a neutral 7.
pH of human blood.
Blood, I think, is neutral or no, or slightly alkaline.
It is slightly alkaline. It is not neutral.
Yes.
Mm, let me just see. The pH of human blood is 7.3.
So it's slightly alkaline.
Slightly not alkaline, slightly basic.
Very basic. Yeah.
Then the most important, the pH of acid rain is been asked. That is, what is the pH of acid rain? Any idea?
It would be less than 7, I know that, but
Be little bit more particular, like 5.6.
yes,
थोड़ा
I will
सा
note those
हाँ
values now. One
तो
year.
just थोड़ा सा आगे पीछे, just have an idea. Then pH of the milk.
7, I think, or no?
No, not
Basic
stable. It is 6.6 because it is sour. It turns sour.
acidic in nature.
Yeah, it is acidic in nature. So in terms of salts, they will definitely ask you question, the color, transition ones. Then in case of acids and bases, many observation based questions are there, right? Then you can the question can be asked from the organic
Which
chemistry.
chapter? What will the from organic chemistry like
Look,
organic?
in organic chemistry, a particular reaction is there called esterification, if you remember very well.
I, Organic chemistry, I did not get that chapter very much.
Okay, so whatever you have just studied, that can also be included. The main chapters that can be asked is acids and bases, right? The
For
main chapter,
analytical,
and analytical, obviously. Then the experiments can be done because this hydrosulfuric acid chapter, the experiment can't be done in laboratory, obviously. Nitric acid you cannot place in laboratory. Then ammonia, you can just have a reading, and the organic chemistry, you can have a reading, just a simple reading, the reaction. If you have not studied, just go through a reading, just normal reading. And the
so
last one,
basically, I have to study in this evening the whole textbook.
no, not
In
whole
the night.
textbook. Go through lesson number 3, go through lesson numbers 8, organic chemistry. And if you're just going through the crash course, so go through lesson number 9. It will just give you a thorough revision.
Yes, ma'am.
The
And
last one,
chemical
Yeah.
bonding and those all things they will, I think. How will they
No,
ask
in
in practical?
practicals it has not been asked. Practicals में नहीं पूछे जाते हैं ये.
Mole concept भी नहीं.
नहीं, practicals में नहीं पूछे जाते हैं.
Metallurgy और in electrolysis तो आ सकता है.
हल्का
I think.
हल्का. Very light chances. If your teacher is taking from the entire syllabus, तब तो everything you have to study. But only from the practical she will be going to ask. Then the particular
But
chapter.
the teacher told us that she could ask from anywhere in the book. So
Anywhere in the book means you have to just take the
but she
reading.
told us that not to study the chapters like mole concept and metallurgy and electrolysis. Rest all
Huh.
we have to study.
That I also told you that 4, 5, 6 is not the practical based or that kind of Viva type of questions. Yeah.
Yes, ma'am. Thank you,
Okay.
ma'am.
Yes. Welcome.